Okay, Math 31. Some of you have asked, I honestly think that this is easier than 30-1 because it just flows much nicer. There was some overlap in 30-1. You guys remember the transformations was throughout almost the entire course, but a lot of the other stuff was different from one chapter to the next, or one unit to the next at least. The nice thing about Math 31 is that it just flows. Okay, we're just going to keep learning more stuff, and we're going to keep using it, building towards the very end when we learn about something called integration. But the first part of the course, most of it is based on something known as derivatives. So we're going to see what a derivative of a function is, and we're going to see the different uses of derivatives of functions. But leading into derivatives, we learned about something called limits, and we're going to evaluate limits. And the concept of a limit is asking. It's asking what is the value of a function approaching as x, or whatever the variable is, approaches a certain value. It's not what is the value of that function at the value of x, because in many cases that value of x is going to be a non-permissible value. So you can't evaluate the limit at that number. The limit is just a function. It's an equation. Okay? It could be a linear function. It could be a quadratic, a third degree, a fourth degree. It doesn't matter. But you're going to have some expression. Sometimes they're rational expressions. So you're going to have some expression, and you're going to be asked to find what is the value of that function as x, or whatever the variable is, gets closer and closer to a certain number. In many cases, that number will be a non-permissive value. So we need different tricks that we can use to evaluate that limit. And one of those tricks that we will use is factoring the function. And so we're going to start by doing some reviewing of factoring. The most basic factoring that we have dealt with in the past is a common factor. And when you're asked to factor an expression or factor a polynomial, you keep factoring until you cannot factor anymore. But the first thing you always look for is a common factor. And in this first one, there's a common factor of 3 that we would take out. And to get what's left inside the bracket, you divide each term by that common factor. I guess I forgot to take attendance. Josh, is that you? Okay. Nathan Barrett is not here. Luigi is, Jihad is, Brighton, Zoe, Scott, Ben. Ty is not here. Fabienne, yeah? Yep. Avia, Kylie, and Gwyneth are here. Okay. Same thing with the second one. There's a common factor there. The common factor would be the letters A, B. Each term has at least one A in there as well as one B. So if you divide each term by the common factor, you'll get A plus B. There's your factors. This third one is a trinomial. Trinomials are factored a little bit different. The front terms of each binomial have to multiply to get k squared. So that would make our first term in each binomial k. And then we're looking for two numbers that multiply to get negative 24, add to get negative 5. It would be negative 8 and positive 3. Doesn't matter what order those are in. You could have the positive 3 first and negative 8 second. But there's your factors. And remember, you can always multiply out factors to make sure you get what you start with. If you multiply the k's together, that gives you your k squared. The outer product will be 3k, the inner negative 8k. 3k minus 8k is negative 5k. And then the last negative 8 times 3 is negative 24. Right, but we always look for a common factor first. And so for question 4, there's a common factor of 2 that we would take out first. And that trinomial that's left, in this case, can be factored again. P times P will give us our P squared. And then two numbers that multiply to get positive 9, add to get negative 6, would be negative 3 and negative 3. And you could write this as 2 bracket P minus 3 all squared. Number 5 is another type of factoring, that's difference of squares. Whenever you have a binomial, both terms are perfect squares and a minus sign in between, that's difference of two perfect squares, or difference of squares. Whenever you multiply difference of squares, you get conjugates. Conjugates are binomials that have the same terms but the opposite sign in between. The square root of x to the fourth is x squared. So those go in the first position of each binomial. The square root of 4 is 2. One's a plus, one's a minus. And normally that's where you would stop. But we're going to see in this course, we'll actually go one step further. Because that second factor, x squared minus 2, we can write that as a difference of squares again. And you might be saying, well, hang on, 2 isn't a perfect square, and you're right. But instead of writing it as a decimal, we'll write it as root 2. This would be x plus root 2, x minus root 2. The square root of 2 is root 2. Well, you could, but then you'd have to have the square root of x and then the square root of the square root of 2. So we wouldn't go any further. And again, these are tricks that we're going to be using to help us evaluate those limits. And as we get into it, you're going to see it'll be obvious when you need to do this or not. Because the whole point of doing this is we're going to see is so that we can cancel. Cancel factors on the top and bottom to get rid of that non-permissive value. The factor that's giving us a non-permissive value on the denominator, we want to try and get rid of that. And so this is one of the steps that we will do. Question 6, there's a common factor of a there. Take it out, we'll get a squared minus 25, which is, again, difference of squares. Factors will be a plus 5, a minus 5. Question 7, there's a common factor of 3 there. Take it out, you'll get p squared minus 25, which again is a difference of squares. Just like the last one, only the variable is different. Question 8, we call these type 2 trinomials because the initial term has a coefficient other than 1. This one has an initial term coefficient of 2. So 2m and m multiply to get 2m squared. The last terms have to multiply to get negative 3, and when we FOIL it out, we have to get a positive 5m in the middle, which will work if you have a plus 3 at the end of the second binomial and a minus 1 at the end of the first. The outer product is 6m, take away 1m gives you your 5m in the middle. Same thing with question 9. Now in this case here, what you have to look at is there are different possibilities for that first terms. It could be a 6n and a 1n or a 3n and a 2n. I normally start with the possibilities that are closest together. 3 and 2 are closer together than 6 and 1. If I can't make this work, then I'll go try and use 6n and 1n. The last term multiply to get positive 5. So I think if I put a minus 5 there and a minus 1 there, that'll give us the last term of positive 5. The outer products are negative 15n. The inner products negative 2n. They combine to give us negative 17n. So there's the factors. Okay, question 10. This is also a type 2 trinomial. The front terms multiply to get 16x squared. So let's try 4x and 4x. The last terms multiply to get positive 1. So the signs have to be the same, and because the middle term is negative, I'll put negative 1s at the end of both those binomials. The front terms multiply to get 16x squared. The outer product is negative 4x. The inner product is also negative 4x. They combine to give us negative 8x. And the last terms do multiply to get plus 1. So this one could also be written as 4x minus 1 all squared. This is an example of a perfect square trinomial because you can take the square root of it. What's the square root of that trinomial? What is the square root of that trinomial? Yes, it's 4x minus 1. You can't take the square root of the original expression, but the factored expression is 4x minus 1 all squared. If you take the square root of that, you're just left with 4x minus 1. That's why they're called perfect square trinomials. This next one, the front terms multiply to get m to the fourth. There's no common factor there, so we factor it like we factored our other trinomials. So m squared times m squared will give us m to the fourth. And again, we're looking for two numbers that multiply to get negative 36, add to get positive 5. I think positive 9 and negative 4 work. They multiply to get negative 36. The front terms multiply to get m to the fourth. The outer products will be negative 4m squared. The inner products plus 9m squared. You're left with plus 5m squared in the middle. You cannot factor a sum of squares, but m squared minus 4 is a difference of squares. M plus 2, m minus 2. So there's the complete factors. Question 12, there's a common factor of 4 there. And that trinomial can be factored further. So there's the factors. Question 13, there's a common factor of 2. And let's see if we can factor that trinomial that we're left with. So the front terms multiply to get 3y squared. That's why I have a 3y and a 1y. The last terms multiply to get negative 7. And when I FOIL it, I have to get a negative 20y in the middle. I think the negative 7 there and the plus 1 there will work. The outer products are negative 21y. The inner products are plus 1y. They simplify to negative 20y. So there's our factors. This next one is a difference of squares. You have two terms. The first term just happens to be a binomial. There's your first term. The second term is 9s squared. They're both perfect squares, and there's a minus sign in between. So remember to factor a difference of squares. The square root of 2s minus 1 all squared is 2s minus 1. The square root of 9s squared is 3s. One's a plus, one's a minus. And now you can simplify because 2s and 3s gives us 5s minus 1. And 2s take away 3s is negative 1s minus 1. And we always say that we can check by multiplying out. And in this case here, what you'd have to do to check is you'd have to simplify the original expression. If you square 2s minus 1 by squaring the first term, multiply the two terms together and double gives you negative 4s. Square the last term gives you a plus 1 minus 9s squared. 4s squared take away 9s squared is negative 5s squared. So if you expand out the original expression, that's what you get. Well, you should get the same thing if you expand out our factors. 5s times negative s is negative 5s squared, which matches the first term that we got above. The outer products would be negative 5s. The inner products would be positive 1s. Negative 5 plus 1 is negative 4s, which matches that middle term above. And the last term is negative 1 times negative 1 is plus 1. So it checks. Okay, it checks. Number 15 is a difference of squares. There's no common factor. Remember, to factor a difference of squares, you're taking the square root of both terms. The square root of d to the 8th is d to the 4th. If you multiply d to the 4th times d to the 4th, remember you're adding the exponents together and keeping the base the same. So it doesn't matter that 8 is not a perfect square. That's not how you work with exponents. Okay, Brighton? The last term, 16, the square root of that is 4. One's a plus, one's a minus. D to the 4th minus 4 can be factored again. You cannot factor sum of squares, but you can factor difference of squares. Square root of d to the 4th is d squared. Square root of 4 is 2. One's a plus, one's a minus. And then, like we saw earlier, that d squared minus 2, we can factor it one more time. It would be d plus root 2, d minus root 2. And there's the factors. Okay? These next ones are difference of squares, like question 14 above, but the difference is that the binomial squared is at the end instead of the beginning. So we have to be careful with our signs on this one. The initial step, though, is recognizing that it's difference of squares. The square root of 25a squared is 5a. The square root of 3a take away 4 all squared is 3a take away 4. One's a plus, and that's no problem, but the second one is a minus. And notice I'm putting the 3a take away 4 in brackets, and a minus sign in front of the bracket changes all the signs inside. So that's what I'm talking about when I'm saying we need to be careful with the signs here. A plus sign changes nothing, so you have 5a plus 3a, which is 8a take away 4. But for the second one, you got the minus sign in front of the bracket. It changes all the signs inside. 5a take away 3a is 2a, and the negative 4 becomes a positive 4 because of the negative in front of the bracket. And we're not done on this one, because when you're asked to factor, you keep factoring until you can't factor anymore. And in the first binomial, there's a common factor of 4 to take out, which leaves us with 2a minus 1. The second bracket, there's a common factor of 2 to take out, which leaves us with a plus 2. And we multiply the 4 and the 2 together, and there's the final factors. So with 17, you have to basically follow the same procedure. The square root of 3d plus 4 all squared is 3d plus 4. The square root of 3d take away 7 all squared is 3d take away 7. One's a plus, one's a minus. Plus sign in front of the bracket changes nothing. So 3d plus 3d is 6d. 4 take away 7 is negative 3. But in the second set of brackets, you have a minus sign in front of that second bracket. So that changes all the signs inside. And because of that, the 3Ds will cancel. It'll be 3D, take away 3D. Then you have 4 plus 7, which is 11. Common factor of 3 out of the first one. And then multiply the 3 and the 11 together. And there's the final factors. And so like we did before, you could check that by squaring both these binomials, subtracting the second expression from the first, and you should get an expression that is equal to what we have written down there. Something new, you can factor sum and difference of cubes. Okay? You can only factor difference of squares, not sum of squares, but for sum and difference of cubes, you can factor them both. And what you have to do is remember the pattern. So here's the pattern. The initial step is the same no matter whether it's sum or difference. What changes is the sign pattern. So if you're factoring a difference of cubes, you've got a cubed, take away b cubed. Those are both perfect cubes. The cube root of a cubed is a, and the cube root of b cubed is b. So that's where the a and the b's come from. And you see it doesn't matter whether it's sum or difference of cubes. That first factor has an a and a b in it. A and a b. Then, to get the second factor, which is a trinomial, you square the a, which gives you the a squared. That's the same in both of them. You multiply the two together, give you ab. That's the same in both of them. And you square the last term, which is b squared. It's the same in both of them. What's different is the sign pattern. For difference of cubes, the sign pattern is minus, plus, plus. For sum of cubes, it's plus, minus, plus. You need to remember that pattern to factor sum and difference of cubes. So this first one is a sum of cubes. Those are both perfect cubes. So the cube root of x cubed is x. The cube root of 27 is 3. To get the terms for the trinomial, square the x, multiply the 3 and the x together, square the 3. And because we're factoring sum of cubes, the sign pattern is plus, minus, plus. Those are factors. If we check by multiplying out, x times x squared is x cubed. So I'm going to multiply everything here first by the x. So I'll get minus 3x squared plus 9x. Then I'll multiply all three terms by the positive 3. And then when I simplify, negative 3x squared plus 3x squareds, they cancel. Positive 9x minus 9x, they cancel. I'm just left with x cubed plus 27. So it checks. Right? But these are the factors. And we just check to make sure. P cubed minus 1 is a difference of cubes. The cube root of p cubed is p. Cube root of 1 is 1. Square the p, multiply them together, square the 1. The sign pattern for difference of cubes is minus, plus, plus. There's your factors, which again you can check by multiplying them out. Question 20 is a difference of cubes. The cube root of 8a cubed is 2a. The cube root of 125b cubed is 5b. Square the 2a gives us 4a squared. Multiply the two terms together gives us 10ab. Square the 5b gives us 25b squared. Sign pattern for difference of cubes again is minus, plus, plus. There's your factors, which again, if you want, you can check by multiplying them out. For this next one, neither 128 nor 2000 are perfect cubes, but there's a common factor that we can take out here, and the greatest common factor is actually 16n. When you divide 128 by 16, you'll get 8. And when you divide 2000 by 16, you get 125. So this will give us 16n cubed plus 125p cubed. So you can't forget about your common factor. It's one of your factors. It has to be stated in your solution. I put a 16 there when it should have been 8. The cube root of 8n cubed is 2n. The cube root of 125p cubed is 5p. Square the 2n, multiply them together, square the 5p, and the sign pattern for sum of cubes is plus minus plus. So there's the final factors. And as we learned in 30-1, sometimes we use factor theorem to factor third and fourth degree polynomials. Remember that a polynomial p at x has x minus a as a factor if and only if p at a equals 0. Now in Math 30-1, we use the graphing calculator to help us find that first factor. You will not be allowed to use graphing calculators in this course though. And that is consistent with what happens in calculus courses at college and universities. You know that you use graphing calculators. So you have to be able to do the algebra here. But I know we mentioned it in 30-1. We have what are known as our potential integral zeros. The numbers that we're going to start with, that we're going to start checking with, will come from the constant term, factors of the constant term, which in this case is -6. So our potential integral zeros they are the factors of -6, which are plus and minus 1, 2, 3, and 6. These are the different combinations of numbers that could be multiplied together to get -6. So if you want to know if positive 1 is a 0, if p at 1 equals 0, then x minus 1 is a factor. And remember, there's two ways that we can do this. You can find out what p at 1 is. Remainder theorem says if you want to know what the remainder is when you divide by, if you divide a polynomial by a binomial x minus a, you can determine what the remainder would be by evaluating for p at a. So if you want to know if x minus 1 is a factor, we evaluate for p at 1. If you get 0 as an answer, that means that x minus 1 is a factor. It tells us that the remainder is 0 when you divide by x minus 1. So you'll get 1 cubed plus 4 times 1 squared plus 1 take away 6. You'll get 1 plus 4 plus 1 take away 6, which is 0. So p at 1 does equal 0. Remember, p at a gives you the remainder when you divide by x minus a. And if the remainder is 0, that means that x minus a divides evenly into the polynomial. If it divides evenly in, that means it's a factor. So to factor this, then remember, we use synthetic division. And we often changed it to x plus 1 to allow us to add as we were going through this. And that is being divided into 1x cubed plus 4x squared plus 1x take away 6. Remember, if there's any missing powers, you have to include them with coefficients of 0, and you also need to make sure they are in order of descending power, which they are. There's no missing powers, it's in the right order. That first coefficients get copied down, then we multiply and add. 5 times 1 is plus 5, and we add. 1 times 6 is plus 6, we add and get our remainder of 0. So not only does this tell us that x minus 1 is a factor, but the numbers at the bottom give us the coefficients of the quotient. We divided a third degree by a first, X cubed divided by x gives us x squared. That's 1x squared plus 5x plus 6, right? And that quadratic can be factored to x plus 2, x plus 3. So there's the complete factors. Okay, let's skip down to number 4 on the next page, a fourth degree polynomial. Our potential integral zeros again come from the constant term. Which shorter lists than the last one, because 3 is a prime number, it's only plus and minus 1 or plus and minus 3. So in the last example, we used remainder theorem, but we can go straight to synthetic division. To see if positive 1 is a 0, we would normally divide by x minus 1. But then we change it to x plus 1 so we can add as we're going. And that's being divided into 1x to the fourth plus 1x cubed. Notice there's no x squared term here, so we have to include it with a coefficient of 0. So that 0 represents 0x squareds. 1 times 1 is plus 1, and we add. 1 times 2 is plus 2, and we add. 1 times 2 is plus 2, and we add. 1 times 5 is plus 5, and we add. We do not get a remainder of 0. That means that x minus 1 does not divide evenly into the polynomial. X minus 1 is not a factor. So if we want to see if negative 1 is a 0, that means x plus 1 would be a factor. We'll change it to x minus 1 so we can add as we're going along. One times 1 is negative 1. We add and get a remainder of 0. So we add and get a remainder of 0. 0 times negative 1 is 0. Add, get a remainder of 0. 0 times negative 1 is 0. Add and get a remainder of 3. 3 times negative 1 is negative 3. We get a remainder of 0. So x plus 1 is a factor. Our factors are x plus 1. In this case, we divided a fourth degree polynomial by a first. That'll give us an x cubed. It's 1x cubed plus 3. There's your factors. Now you could factor x cubed plus 3 as a sum of cubes. You would just have to say the cube root of 3 would be the cube root of 3. Okay? And if you needed to do that, like I said, it'll be obvious. When we get into limits, you'll see what I'm talking about. But there are no more factors for x cubed minus 3. Okay, so there's your final factors. Okay. So we'll stop there. You guys can be able to go down and get your textbooks. Actually, let's go and look at these next ones first. When factoring expressions that involve rational or negative exponents, we use the laws of exponents. So when you're looking for a common factor, the coefficients is no problem. You got coefficients of 2, 4, and 6. So just looking at the coefficients, the greatest common factor would be 2. But then we also have to pull out a common factor for the powers. And what you need to remember is that you need to take out the the common factor of the power that is the smallest. In this case, the smallest power here is negative 1/2. Our greatest common factor is 2x to the negative 1/2. And remember, to get what's inside the bracket, you divide each term by that common factor. So 2 divided by 2 cancels. You'll just get 1x. And then to get the power on x, you divide the powers as well. You're going to divide x to the 3/2 by x to the negative 1/2. And when you're dividing powers with the same base, remember you subtract the exponents and keep the base the same. So this will be x to the 3/2 take away negative 1/2. When you divide powers with the same base, you subtract the exponents and you keep the base the same. You're dividing x to the 3/2 by x to the negative 1/2. Subtract the exponents. The next term, 4 divided by 2 is plus 2, and when you divide the powers, again, you subtract the exponents. And then for the last term, negative 6 divided by 2 is negative 3, and when you divide the powers, you subtract the exponents. It'll be negative 1/2 take away negative 1/2. And so when you're subtracting those exponents, in all three cases, you have a minus minus, which becomes a plus positive. So you're going to have 3/2 plus 1/2, which is 4/2, or 2. For the second term, 1/2 take away negative 1/2. Again, a minus minus becomes a plus positive. It becomes 1/2 plus 1/2, which is 1. And for the last one, it'll be negative 1/2 plus 1/2, which is 0. And x to the 0 is 1. So that last term is just minus 3. And you're going to x squared plus 2x take away 3, which factors to x plus 3, x minus 1, and there's the final factors. Again, x to the 0 is just 1, so you're just left with 3 times 1, or 3. Okay, there's your factors. Question 2. The greatest common factor involves a coefficient, which will be 3, and the smallest power on x, which is x to the negative 1/3. To get what's inside the brackets, divide each term by the common factor. 3 divided by 3 cancels. You're going to have x to the 5/3 take away negative 1/3. For the second term, 6 divided by 3 is positive 2. And you're going to have x to the 2/3 take away negative 1/3. And negative 9 divided by 3 is negative 3. And then you'll have x to the negative 1/3 take away negative 1/3. 5/3 take away negative 1/3 becomes 5/3 plus 1/3, which is 6/3, or 2. 2/3 take away negative 1/3. The minus minus becomes a plus positive. You'll get x to the 3/3, which is just 1. And the last one, negative 1/3 plus 1/3 is 0. So you get x squared plus 2x minus 3, which is the same quadratic we got in the last one. So it'll be x plus 3, x minus 1. That's just a coincidence. Got the same quadratic to factor, but the initial term is different. Question 3. The common factor there will, from the coefficients, be 4, and from the ends, again, it's the smallest power on n, which is -3/4. To get what's inside the bracket, we divide. 8 divided by 4 is 2. When you divide the ends, it'll be 5/4 take away -3/4. The minus minus becomes a plus positive. It will be 5/4 plus 3/4, which is 8/4, or 2. -12 divided by 4 is -3. 1/4 minus -3/4 becomes 1/4 plus 3/4, which is 4/4, or 1. And -8 divided by 4 is -2. And when you divide the n to the -3/4 by itself, they cancel. And let's see if we can factor that further. So -2 there and +1 there will work because the outer products will be -4n plus 1n in the middle gives us -3n. And for the last one, there is no common factor with the coefficients, just the exponent. Remember, you always take out the power that's the smallest. Now that first one, 1 is just 1x to the 0. That first term in the original polynomial was just the number 1, but you can write it with a power of x as x to the power 0, which you need to do so that when you divide each term by the common factor, you have an x there. So 1 divided by 1 is 1. When you divide the x's, it'll be 0 take away -2, which will be 0 plus 2, x squared. When you divide the middle term by the common factor, x divided by x give you +1. -1 divided by, -1 take away -2 become -1 plus 2, which is x to the 1. And -12 divided by 1 is -12. When you divide the x to the -2's by themselves, they cancel. And this factors to x plus 4, x minus 3. So there's the complete factors. Okay. So in your textbook, you're going to do on page 3, questions 1 through 4. I will post the solutions to Google Classroom so you can check your answers. And you guys can go down and get your textbooks at the library. Okay, you got your student ID numbers, everyone? Yeah?
I might memorize.
Okay.
Gosh, you memorize 6 numbers. 5 numbers. 17, 6, 4, 5. Yeah.